last section in this chapter is section 3.6 on variation. Variation is sometimes also called proportionality. If we say things are proportional, that's also the same as they vary together. So in math and science, we often describe the relationship between two quantities in terms of proportionality or variation. When one quantity is a constant times another quantity, we say that the two quantities vary directly. So that's our first type of variation. They vary directly, and we say this relationship is linear, so it's y equals k times x. This would say y varies directly with x. Here, y varies directly with x, where k is our proportionality constant, and we say k is positive. When two quantities vary inversely, then, so this is varying inversely, we say that this one is y equals k divided by x. So this is similar to what we saw in section 3.5 with our rational functions where we have 1 over x. And then when there are more than two quantities and they vary together or vary jointly, then we describe it as y equals k times x times z. Let's look at an example. The area of a rectangle varies directly. So the area, so A is going to be the area of our rectangle, and it varies directly with the length. So we have area and we have length. So let's let L equal the length of our rectangle. And what the problem tells us is the area varies directly, which is K times the length. So it tells us A equals K times L. Now we know from basic geometry that K is actually the width, but let's pretend we don't, and let's plug in some values and see if we can solve for K. So it says if the area is 50 square meters when the length is 10 meters, find the area when the length is 25. So let's start with the area is 50 when the length is 10. So I have 50 equals k times 10, and we can undo that by dividing both sides by 10. So that tells us that 5 is equal to k, which means that we can now rewrite our formula. We now have A equals k, which is 5 times L. And it says now find A when L is 25. So let's say A equals 5 times 25, or 125 square meters. If y varies inversely as x and y is 20 when x is 1/4, find y when x is 15. So when we said y varies inversely as x, that was y equals k over x. Inversely means over. So k over x. And so then we said y is 20 when x is 1/4. So if we're dividing by 1/4, the way we can undo it is multiplying by 1/4. And that will cancel out these guys. And 20 divided by 4, right? 20 times 1/4 is 20 over 4 is k. So 5 equals k. So when we rewrite our formula, now we have y equals 5 over x. So we've gotten those two guys taken care of. Now we want to find out when x is 15. So when y equals 5 over 15 then, and y is 1 over 3. Example 3 says simple interest. This is about simple interest. Simple interest varies jointly, which means we have a bunch of variables that are going to be multiplied together. So simple interest varies jointly as the principal in time. So I will be our interest. We'll have P is our principal. Now that's the amount we invested, right? That's our original amount invested. Originally, there we go. And time we'll call T. and we'll put it in years. Okay? So if $1,000 is invested for 2 years and it earns $70 in interest, find the amount of interest earned by $5,000 for 5 years. Well, we know that our interest, I, varies jointly. So K times principal and time. So K, P, and T. So what we have to do now, plug in the different values for I. We don't know K yet. Here's our T is 2 years. Right? Oh, but we made a mistake. Is the I really $1,000 invested, or is I the $70 in interest? So this is where these problems can get a little challenging. The interest is actually our I, so this is not I, but this is our principal, the amount we invested initially. So if we invested $1,000 initially for 2 years, and it earns 70 in interest, we want to find the amount of interest earned by 5,000 over 5 years. So let's first of all figure out what K is. We know that I is the $70 and it equals our K times our principal, which we said was the 1,000 that we started with, and our time, which is 2 years. So really we get 70 equals 2,000 K. Or in this case, if we divide both sides by 2,000, 70 divided by 2,000 is K, or K is 0.035. In this case, that's our interest. It's 3.5% simple interest. We know this is interest because we've done I equals P times R times T problems before, so we can see that we've done similar types of problems like this before. So now let's rewrite our formula as I equals K, which we just said is 0.035 times our principal times our time. And now it wants us to find the amount of interest. So find I earned by 5,000 as P for 5 years T. So we want to say I equals 0.035 times our principal, which is 5,000, and our time, which is 5 years. So if we take our 0.035 and we multiply it by 5,000 and again by 5, we end up with $875 in interest. And that's varying jointly. Let's see what our last example has in store for us for this section. The distance that a person can see to the horizon on a clear day from a point above the surface of the earth varies directly as the square root of the height at that point. If a person is 144 meters above the surface of the earth and they can see 18 kilometers to the horizon, how far can a person see to the horizon from a point 64 meters above the surface? So what we have to think about here is, here's Earth's surface, right? We know that the Earth's surface is curved because it's round. And depending on where we are, somewhere, let's say we've got a person that is up here, maybe in a building or on top of a building or something. And they're looking out the window. And the distance they can see to their horizon, D, right? So we'll say D is the distance a person can see to the horizon, right? On a clear day from a point above the surface, we'll call this a height above the surface. H is the height above the surface. So above the surface of the earth, right? So the distance a person can see to the horizon on a clear day from a point above the surface of earth varies directly. Oh, so the distance, right? The distance that they can see varies directly. So K times the square root of the height at that point. So it's going to be K times the square root of H. And then the numbers that we can plug in are We've got a person is 144 meters above the surface. This is a height. And then they can see 18 kilometers. That is a D. So we know that we've got 18 equals K times the square root of 144. Or this is 18 equals the square root of 144 is 12. So this would be 12K. If we divide both sides by 12, 18 over 12 equals K. If we factor out what's common and cancel, that'll be 6's. This would be 3 over 2 is our K. So we can rewrite our formula as D equals 3/2 times the square root of H. And it says, how far can a person see to the horizon? So what is D? When they are 64 meters above, when H is 64. So D is 3/2 times the square root of 64. And the square root of 64 is 8. So 3/2 times 8, or 24 over 2, which is 12. And our units here are meters. So the distance that that person can see to the horizon is 12 meters. Make sure you finish the online homework for section 3.6.